Hi, I'm Allison Freeland in the New York City office of the American University of Beirut. Welcome to another New York Beirut briefing in which faculty, students, invited guests, and experts discuss research from the Arab world. Today's episode is on climate change in the Middle East, its dire consequences, and some possible policy responses. If you'd like to see the entire briefing, you can do so on the AUB YouTube channel. Welcome.
Most Gulf countries, on average, use around 600 liters per person per day. That is equivalent to, or more than what the US citizens use. And in parts of the Middle East, it's around 150 liters per person per day. So we should start with reducing that use. And then once you get to some level that is manageable, then you can start, and if then the energy use is still problematic, then you have to find other means. The reason we're pushing for the water energy food nexus on a regional level is that there are countries in the region that are water rich.
Also, if you look at water productivity, this region, you would think that, given that it's the most water scarce region and that should lead you to manage water in a good way, you'd think that the water productivity would be the highest. But actually, if you make a global comparison, it's the lowest in the world, in the region. Part of that is, of course, because a lot of water, as Nadim was rightly saying, goes to agriculture, which doesn't produce as much dollars per cubic meter used. But it's not the whole explanation.
Thinking of urban resilience will require us to really flip upside down the way we look at cities. We cannot look at them as something as a static that's fixed in time. We really need to look at them as dynamic and ever-changing. We cannot, we talk about projections, but we have no clue if these projections are going to materialize the way we do. So a lot of what these frameworks that we're working on are very much about flexibility, about adaptive systems. And I think, a little bit here, and I think the work with IFI, with Nadim as well, that we're working on urban informal systems, really comes into these ideas.
And the research that we're doing at AV here that I'm involved in relates to multiple scales. I'll start a bit with the urban scale, whereby one study is we're calling it Beirut Whole. So this is Beirut Pollution and Energy Dynamic Model. It's really looking at the urban heat island effect in the context like Beirut, so these elevated temperatures that are existing in the city. And we're looking at the dynamic behavior between the urban heat island effect and its relationship or its association with air pollution.
Yeah, I'm Richard Seeger. I'm a climate scientist at Columbia University Montevideo Observatory. It's very interesting to listen to all this. I've read I want to get back to the issue of the transboundary water agreements. I've read that within the Jordan Basin, Israel and Jordan have worked quite effectively to manage reduced flows there. But I'm wondering, for the Tigris-Euphrates basins, given the conflicts in all the countries, how are the water agreements between Turkey, Syria and Iraq that govern those river flows holding up right now? Or are they completely gone?
Growing as a daughter of an agriculture in Tunisia, I lived all my life when I was young in Tunisia with this question coming from my father: please go and see if it rains outside. So because it's very, very interesting for us, as he's, as I said, he's in agriculture and it's about wheat, about cereals. So listening to you saying, please, Andrew, that groundwater, that Libya, our close neighbor, is using the groundwater and it's harming, there is any problem to the neighborhood? I think the neighbor's country, is it the same groundwater that they are using, and I don't know, is it in the agreement, UN agreement?
My intervention is related to food supply and how to increase it. We're trying as an agricultural engineer to shift the production without using pesticides and using or depending more on integrated pest management and organic production. And here we are concerned because with the climate change, we have increased minimum temperature and lower humidity. So applying these techniques is getting more hard, and thus treating diseases and pests will be also hard.